Number 6. Okay, so this is where I left off last night. I was so exhausted. I went to bed at like 8 o'clock. Okay, and you should get a good night's sleep too. I see some of you guys are kind of sleep deprived. And okay, so let's take a look at number 6. Once again, the way we determine the vertical asymptote is we just set that denominator equal to 0. So therefore, x is going to be -8 and then -4. Okay? And then to find the horizontal asymptote, we're going to isolate x. So we have y equals x plus 3 over 2x plus 8. Multiply both sides by 2x plus 8. Sides by 2x plus 8. And that's 2xy plus 8y equals x plus 3. Now let's gather the x's on one side and move everything to the other side. And that's 3 minus 8y. Factor out the x. Divide both sides by 2y minus 1. So we get x equals 3 minus 8y. 2 minus 1. Now that we've isolated x, we can just set that denominator equal to 0. So we have 2y equals 1, y equals 1/2. Okay, so the vertical asymptote is going to be x equals -4, and the horizontal asymptote is going to be y equals 1/2. Let's go ahead and start graphing it. So we have -4, plot that, and y equals 1/2. Just like that. Let's test some x values. Pick a x value that is less than. So let's go ahead and pick -5. Put it back into the equation. And so let x equals -5. X equals -5. So that's going to be y equals -5 plus 3 over -10 plus 8. This implies that y equals -2 over -2 equal 1. So we have -5 and 1. -5 and 1. So we know it's going to be over that horizontal asymptote. And I can graph more points on there. Let's try another one. But I know it's going to get closer and closer to y equals 1/2. So I'm just going to do this. Now let's test some points that are greater than -4. I can test. Let x equal, let's try -2. So y equals -2 plus 3 over 2 times is -4 plus 8. This is going to give you 1 over 4. -2. 1/4, which is right here. Somewhere over there. Okay, it's gonna be between. If I really wanted to make this precise, be like right there. Okay, and then let's make it x equals, because I just know it's going to get closer and closer to the asymptote here. Okay, and then maybe try x equals -3. So y equals -3, -3, and then that's going to be 0. Kind of like that. And then I can go ahead and state my domain. So x such that x cannot be -4. Range y such that y cannot be 1/2. Okay? Good job, guys. Next one. We have a square root function. Let's go ahead and graph this. So a parent square root function is going to look like this. Okay, and that little vertex is going to be at 0, 0. Okay, this, let's look at so it, based on this, it went left 6 and down 5. Okay, so left 6 and down 5 right here. That's our starting point. And then this right here is slope. That one is slope, so we can go up 1 and to the right 1. But it only works for that one point. Okay, so we can put some more points in. I mean, we can actually solve it for plus the square root of x plus 6. And figure out where it is in 0. 5 equals the square root of, and square both sides. 25 equals x plus 6. And then -6 minus 6. X equals 19. Oh, that's not going to fit. So 19 comma 0 doesn't fit. It's going to be all the way over here somewhere. Okay, like even further than that. So let's go ahead and let x equal 0. That's going to be y equals -5 plus square root of 6. Square root of 6, -5 plus the square root of 6. So that y is going to be -2.6. Or 0, -2.56, somewhere here. If I was really smart, I'd put an x in that makes it a perfect square. So I can put 3 in. Right? Because that's going to make it a perfect square. So y is equal to -5 plus, that's the square root of 9. Haha! 5 plus 3. So y equals -2. 3 -2. Right there. And there is my function. Now let's go ahead and find the domain. Now I could have done the domain. I could base it on this right here. Left 6 and down 5. The domain is going to get affected by the movement from left to right. So x such that x is going to be greater than or equal to 6. And range is going to be y such that y is going to be greater than or equal to 5, -5. Okay? Good job, guys. So here we are. We have a function inside of a function. Okay, we have a quadratic and we have a rational function. So like I told you, the asymptotes only exist with rational functions. It really exists with rational functions. Okay? So because this is a rational function, we treat it, try to find the asymptotes, we treat it like a rational function. So for the vertical asymptote, we're going to set the denominator equal to 0. Okay, and then let's go ahead and take the negatives out. And then we're going to factor. So that's x minus 2, x plus 1. And so that's x equals 2 and x equals negative 1. Okay, so that is our vertical asymptotes. Treat this like the rational function, horizontal asymptote. Here we have a constant. That constant is not 0. So that horizontal asymptote is going to be y equals 0. Okay? That's what y cannot be, because 1 is not 0. Okay. Now, when we look at the domain of this function, okay. Sorry, my dog Leo was barking. Okay. When we look at the domain of the function, I want you to think like this. When we have a function inside of a function, which is something that I just came up with, this function is inside of a rational function. The quadratic is inside of a rational function. The domain of a quadratic is all real numbers. Okay, now, because it is a denominator of this rational function, it's going to get restricted by the properties of a rational function. And so the properties of a rational function is that the denominator cannot be 0. So I'm just going to take the denominator, whatever the denominator is, and just set it equal to 0, which is what we did with the vertical asymptote. Okay, and then once we found that our vertical asymptote is x equals 2 and x equals negative 1, those are the things that, that are going to be restricted. So therefore, the domain of this, let's go ahead and write it here, is going to be x such that x cannot be 2 and x cannot be negative 1. Okay, because we took this quadratic, and the domain of a quadratic is all real numbers, but when you put it inside of a rational function, it's going to take on, it kind of gets narrowed. It's kind of like a filter. It captures all real numbers, and then it creates that kind of filter where, hey, since it's a rational function, we have to exclude those two that are the properties of a rational function, which is x equals 2 and x equals negative 1. Okay? Now, to find the range, we actually have to graph it. And this is where our difficulty lies. So let's go ahead and draw our asymptotes. Asymptotes are very helpful in graphing they kind of trap, I kind of like, they restrict and they trap the graph. And we know once there's an asymptote and there's a point after the asymptote that it's going to just get closer to the asymptote. And so in that aspect, they're actually easier to draw for me. Okay, so this was x equals -1, and this is x equals 2. So I'm going to find a point that is less than x equals -1. So let's x equals -2. When I put it back, let x equals -2 back into the function, 1 over -2 squared plus -2 plus 2 implies we have a -4 minus 2 plus 2, which implies that it's going to become a negative number. It's going to give you a negative output, so we know that it's going to be below that horizontal asymptote. So -2 right here. And I could just graph this using the asymptotes as a guide. Now, because this is an even function, it's going to be symmetric, okay, by a horizontal, a vertical line, okay? So I know that I can test it, a number that's greater than 2, which is 3, so y equals 1 over -9. And this produces such a negative number when you square it. I know it's going to be a negative number. 1, -10. Oh, wait. Why did I put a negative out there? 1 over negative, what is it, 2. I can't do -3 plus 2 for some reason. -10, right? 3 minus 2, 1, -1. Okay, so I know that 3, it's going to be like a minuscule number. It's getting closer and closer to this asymptote. Now, a lot of you guys in class were like, hey, quadratic with an a negative, that's negative. That means that the quadratic is going to be concave down. It's going to look something like this. Not when you put it in a rational function. Now, this is the really cool thing. Okay, when you take a quadratic and make it the denominator of your rational function, it is going to create a parabola that is opposite than the actual quadratic itself. So if this was an actual positive, something like x squared plus x squared and minus x minus 2, you're actually going to have a graph with some asymptotes. And these two rational function parts of the graph are going to be over, it's going to be greater than 0. And then this parabola down here is going to be concave down. Okay. So we know that this is going to be concave up. And the actual rational portion of it is going to be the ones that are below, okay, y equals 0. But in order to find that, I have to find the midpoint, okay? So I have to find the midpoint between -1 and 2. So to find the midpoint, I'm going to do 2 minus -1 divided by 2. So that is going to be 3/2. Okay. Well, it's not really the midpoint. So when I talk about midpoint, I mean the distance. Okay, it's not the actual point on the coordinate. Okay, so in order to find that, we know that we have to travel 1.5 from either 2 going that way to the left, or from -1 going to the positive side. So we can either take 2 and subtract it by 1.5 to actually find the coordinate, okay, that where x is, to plot it. Okay, so that gives me a 0.5. And I could have taken -1 and I could have added 1.5, which also gives me 0.5. And that 0.5 is the middle point between -1 and 2. Okay, now after I've found my x value for the midpoint, I'm going to have to find my y value. I go back into the function. Let's go ahead and write it down. We're going to say let x equals 0.5, y equals 1 over negative, it's 1/2 squared plus 1/2 plus 2. Okay. Now that is y equals 1 over negative 1/4 plus 1/2 plus 2. It's 1 over, I'm going to do common denominator 4 minus 1 plus 2, and then plus 8. It's going to be 1 over 10 negative 9 over 4. Take the reciprocal, negative 4 over 9. I have no idea where I got that negative. Positive 9 over 4. So it's positive 4 over 9. Okay, so my midpoint, or that vertex of that parabola, is going to be 1/2 comma 4 over 9. So let's go ahead and graph it. 1/2 and 4 over 9 is 0.4. Somewhere here. Okay. It's going to be the lowest point right here. Ba-bam. Okay. So if you look at the range, okay, the horizontal asymptote, yes, was y equals 0. But if you look at the range, this area right here, between 0 and 4/9 is not being used. So you have to express that in the range. So your range is now going to be y such that y is going to be less than 0, or y is going to be greater than or equal to 4 over 9. Okay? Good job, guys. Good job. Okay. Next.